The beginning of match race madness. It started with these two cars. The Chevy legend Joe Sherman, his son Steve is a driver, and of course myself. And
side, front wheels in the air. First to the finish line. Fast, race, fast. Joe Sherman racing engines in the orange car. BENALAMEDA racing engines in the yellow car.
we won and lost, and the Joe Sherman Racing team won and lost as well. It was a fairly even contest, and the best time we ever had when you're going heads up and when you test yourself with the best. And Joe is a legend. There's no other way to describe the man. Rest in peace. Please subscribe, like, comment, and share.
Video, I cut it to different segments because the build process on this Motorsport 29 is ongoing, and I'm doing the video as soon as I get the parts coming in, and I go through assembly and setup. But anyway, there's always been a lot of questions. This engine's very misunderstood because when it first came out in 1969, I think, yeah, the Motorsport 29, the heads are way too big, there's not enough compression, and there's not enough caption. Therefore, they're rated very low, but in actuality, they're rated quite high from what is advertising, 375 or something like that. It's probably 450, 500. But anyway, they were not stellar performers because of the reasons I said earlier, but also at the same time, once they are built to the hilt, they will dominate, just like they shown when Glidden ran them in AHRA at 500 cubic inches, not as advantageous as opposed to when IHRA had them at 600 plus cubic inches or mountain motor. They dominated, and the only way the competition can keep up is they have to build basically a hemi head design or semi-hemi. You cannot run a canted valve against a hemi head combination as much. At the same time, also a 4-valve head has got advantages. It's just the way it goes, all right? So a canted valve will not compete evenly with a hemi head. That's why towards the end with NASCAR, they start putting restricted the intake for the big blocks so that the small blocks can compete. Okay, so that said, remember, let me, this part we'll try to learn while going through this video. The hemi head, the pure hemi, like the Chrysler, is straight in to the intake port, out to the exhaust. There's hardly any swirl. Tumble is there, but no swirl. Now the hemi, instead of being front to exhaust, intake to exhaust, straight like this. Okay, what happens is that they tilted it so that you have some kind of mixture motion to enhance the mixing process of the cylinder head. and basically make more power. This is why, if you look at the pro stocks, they're not really a true Hemi. They're more like the Boss Sport 29 configuration, offset to one side. All right, they have some kind of mixture motion in them to basically help the mixing process. Remember, it's not all about flow, and I feel that I think most people would agree with me, is the shape of the port rather than the flow. Okay? Because you have two identical flowing heads, but one is shaped better, then that will make more power. Okay? If you can keep the air fuel homogeneous, if that's the proper word, to keep everything together, air and fuel travel through the port without separating. Okay, and that's where you lose power, because if separating through the intake port, by the time it gets to the combustion chamber, it's probably a lot worse. So if it's together into the intake port, flange or manifold to flange, hopefully it's going to be a lot better by the time it gets to the combustion chamber. There's more chances of this mixed up pretty good, as opposed to having variations and eddy currents inside the combustion chamber, which would equate to loss of power. Because the combustion is instigated or ignited, and there are many different scenarios inside the combustion chamber. Lean spots, rich spots, eddy currents, so forth, so on. You will not get good power, NA, right? And same thing with a blown configuration. If you have, but the only thing with blown by itself, the turbo plus the RPM, has enough mixing motion going on, so it's not quite a concern. Remember, by the time you get to the high RPM, there's more rapid action, okay? And basically right there, swirl and tumble is not quite significant, okay? Because that in itself, the rapid acceleration stop. Okay, it's not flowing continually, it's doing this, all right? Because every time the intake valve closes, the flow gets interrupted, it slams into the valve, and then by the time it opens up again with a strong pull of the exhaust runner, it yanks everything in, and that by itself gives it a lot of mixing motion by itself without tumble and basically swirl. By itself, the stop and go is already shaking things up, right? So it's going to be pretty dark and good. On this 429, 460, they were never as popular as the big block Chevy, like I said, because one thing, the 429 has a 359 stroke, and the 460 has a 385, and that by itself is somewhat lacking, right? Even though the heads may flow better theoretically, but Chevy has the rectangular port, which is good for big cubic inch, high RPM. The Ford, it's either anemic with a standard 429, 460, or you have the SCJ and CJ heads, which is now big, and without the proper compression, it's not going to produce much of anything. And also, besides the stroke advantage of the big block Chevy 454, for example, a 4-inch, that's a big jump from a 359, a 429, or a 385 or 460. Port is king on the street, right? And that also, like I said, symmetrical port is great for racing. Everything all even, the way the intake port approaches the combustion chamber is all even with the Ford, excellent. But on the street, not quite as significant or quite an advantage. And remember also, the big block Chevy having left and right side port has two different port lengths. So 4 of the shorter ports would peak at a higher RPM, and 4 of the longer ports will peak at a lower RPM, giving it a more broader power band. So even though theoretically that's not an advantage, it is. Okay, as far as street is concerned, maybe at high RPM post-stock style or maximum effort NA like NA 10.5 here in the West Coast and other places where they limit the natural aspirated. You can see the symmetrical port has an advantage. Okay, and then the only way you can compete is with symmetrical port big block Chevy. Because the Chryslers have the symmetrical port, the Fords have them too. So those 3 main makes, when you look at, you can fix these things. Just like when you look at the halo-borne injection, the ports, the stacks are shorter and on four and longer on the other one to compensate for a different port length. At the same time, when you look at the carburetor, it's tilted, okay, off to the side to try to help the issue of the uneven port length. Try to get some equal flow into the manifold, or have it be dispersed a more even pattern in there, so you have no lane situation on the end ports or the center ports running through it. That is an issue. So here we are. Let's look at the blocks, starting with the factory 429, 460. Then we go to the rest of the thing and enjoy it. And let me hear your comments. Please like, subscribe, post a comment on the video, and so we could keep this going. Okay, at the same time, I will highlight the difference between the factory block 429, 460, and then the Corvette Boss 429 blocks, what the difference are, and this new Ford Motorsport. Let me make a comment, all right? I'm not knocking Ford SVO, but I feel that they should have somebody out there that are talking to the racers. Just like when they came up with the Boss 302 block. And I showed here the measurement. A high-performance block has a shorter cylinder wall than a factory 5.0 or a 289. Why would they do that? You know for a fact that when they buy an aftermarket block, they're probably going to stroke it or turn absolute high RPM in. Give it a split cylinder wall to put some stability in there. Now, when you're looking at this doggone block, the SVO Boss 302, it's shorter. I was shocked when I saw that, and when I measured it, I was like, how can this be? But this is a lesson. Again, here on the 429, for what we're doing, racing, but not all out. I had a Pro Stock. Here's a picture of it. Aluminum 429, 460 block with small block journals in it, because they run, Pro Stock back then, 500 cubic inch. I think probably 300-400 stroke, somewhere thereabouts. Not really big strokers. They're limited to 498 or 500 cubic inch on the money. And when the factory or the manufacturer doesn't listen or get feedback from the racers, that's when you get in trouble and come up with an inferior product. I'm not saying per se that this 429 is inferior compared to the block that's being made by Eliminator. That is killer. All right, and I will highlight the differences here. For what we're doing, it's more than enough, but I tell you, I'm really disappointed. Because if I don't have the budget for an Eliminator block and I have to run this SVO block for the level of racing I'm doing, or a lot of us are doing, I think it's going to be hurting. And that's not going to be very good as far as block durability. Remember this 429, 460, and the big block Chevy, they are the mini skirted block, meaning the block comes down to the oil pan rail and the main caps are below the oil pan rail. Whereas the Hemis, the Chrysler, they are full skirted blocks. All right. The main cap is straddled in the middle and the FE the same thing, by the oil pan rail that extends down to the main caps, and then you can have a cross bolt. So we have 4-bolt plus a cross bolt. Ain't going anywhere, but still I've seen it bounce, even with that much fasteners or main bolts. Once that thing starts bouncing, it will bounce. There's nothing you can do to stop it. And you can see the transfer of metal. Obviously, when you take out the main cap. And again, like I said earlier today on one of my short videos, the number 2 and number 4 at high RPM, the crank wants to turn to an S. 429, 460, same way. Number 2 and number 4 takes a load of it. And they're the first ones to really get damaged. And you'll see excessive wear. If 2 and 4 are looking good, 1, 3, and 5 would be more. I can bet on that. It's going to be in good shape, right? Except if you have any kind of metal contamination or anything like that. But 2 and 4 takes the brunt of the crank flexing or distortion. Turns to an S and it loads up 2 and 4. There's a part number for this block. This is one of those crate engines, 460, based off a stock block. Here it is. We will compare the difference between the two. This one here is a Ford Motorsport 4-bolt main block. There is quite a big difference in strength. It's a D9 casting. Is a brand new one from Ford Motorsports. And look at this. I will highlight some of the differences, and hopefully you guys can make a better decision. There's nothing wrong with the factory block. It's pretty stout. But this is even more stouter still. But then again, there are issues I have to highlight over here. Now let's start with the good points. Look at here. It's very, very thick. All right? The support that shores up all the main caps. Look at that. All right? That is filled in, and there's a lot of meat. And look at the factory one. Hollowed out. Okay? Here again, not as bad. Still hollowed out, hollowed out, hollowed. There's not much support. Let's look at the other side. Okay? It's filled in quite a bit. Look at here. Again, it is on the weak side. This will be compromised, especially when you got a blower or heavy duty use, perhaps high RPM. Now, let's look at the main saddles. Over here, look how thin this is. When you convert this and machine this off to a 4-bolt main, it is not advisable, because once you drill for even a 7/16 or 3/8, just not enough material there. All right, like some Clevelands that I saw, 4-bolt main, similar, it has broken right here and pulled the whole saddles up, even with a 4-bolt main conversion. Here, look at the difference. All right, it is very, very thick. Now let's look at how it is. All right, look at here, look at here, look at here. All right, and look at there. Another issue. So converting this to 4-bolt main is not really advisable, and I would have second thoughts. Press in freeze plugs, screw in freeze plugs like the Boss 429. Now also put in the Boss 429 here in between. Okay, so there we are. Quite a bit. But here's my issue. Why did they do this? Why did they scallop that? I'd have preferred that to be flat, to have at least a little bit more water inside the block. Okay, especially this drag and drive classes these days. More water you can put in there, the better chance of you keeping the engine cool. Now on the back. 2-piece rear main. Why Ford did this again? Why did they not put a 1-piece rear main here? Cossie has got a 1-piece oil seal. Then you got to modify a little bit to fit it here. I don't like that. You already made a pretty darn good casting. Why not put a rear main? Even with a 350 Windsor, cranked down or cut down. All right? No improvement there. Again, you're looking at the freeze plugs there. Screw in. There's no freeze plugs here. All right? So, there's one there. There's another one there. I don't know if I'd fill this up, how much water this takes as opposed to here. I'm sure the cylinder wall is very thick on the most part. Well, why did they do this? Okay, just like my complaint with the Boss 302 block. You know for a fact that everybody runs, or just about everybody runs a stroker kit. Why did they make the doggone cylinder wall shorter on the Boss 302 block? compared to Ford production. Again, I fault Ford Motorsport for that. Now let's see here. Remember my modification on the front? I drill a hole there to lubricate the distributor gear. Simple modification. Over here on the Motorsport block, not necessary, because when you look here before I push in the bearing, there is an oil passage here to go direct to there and feeds the doggone distributor gear right here. You don't have to drill that little gizmo right there to oil. You get it directly from the bottom of the cam bearing. It feeds to this line right here that you see. Feeds directly to the distributor. So that's a must. When you look at here, it is a Boss. Well, when you look at here, it's basically a Windsor type block. The 460 is not a Cleveland offshoot. It's an oversized Ford Windsor. Now, another concern that I have, I like this little gizmo here to basically position the rods. Basically to position the main cap. But here's my issue. Remember the 351? The firing order is very thin right here because of this passage. It's thinner here, even more. All right? Over here, it's a little thicker, not by much. Again, the small block Windsors, they short is up with a casting, like you show in this picture. With aluminum or a cast iron block, they have that. Here, it's not existent. Okay, like I said, at least that's for far distance, not like the small block. It goes almost here and intersect the oil passage. It really makes it weak. All right? Not much difference that I can feel, but there it is. Okay? Ford should have been listening to the racers to have done that. But that's when I talked to 2X SVO engineers, and sometimes when they don't talk to the racers, this is what you end up with. All right? No, 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 no. All right? This is beautiful, 4-bolt main, splayed. That is great. Otherwise, I have my reservation, and this is going to be used for some serious stuff. Okay, now let's look at the top end. I can tell right off the bat when I stuck my finger in there, and over here on the Motorsport block, it's a lot thicker cylinder wall here. Much, much better. All right, the oiling system is basically unchanged. Same thing there, but you got priority oiling right here. All right, which you don't have with the factory block. So you can see that right there. Again, I stated before, drill that on a stock block, a little pinhole, so that it'll feed the distributor gear. And right here, you can see the line and the little hole. Right here has a little opening to feed from the main and oil the truss plate. All right, it's got positive oiling of the truss plate, which here is just relying on oil pressure leaving the cam bearing to oil the truss plate. And remember, you must use a rotor cam truss plate, not the one that came from the factory, the flat tappet. It will not work, it'll wear out. So you have the oiling there, main, not there. All right,
So here we are. Big difference. Valley area, very similar. It has that one too, just like a factory. All right. So, well, with the weak front and this pre-drilled area, really, when you think about this, it's somewhat thin. It's non-existent here except for the front. This is still kind of thick. You can tell this is thick, but you don't have any of these oiling here. All right. All it is split the block, and you're gonna have issues. Now let's look at the back. The head bolt pattern, indicative, typical Ford. All right. And look at the priority oiling here. You could see right there. All right, the main well. Nothing here. This looks, the deck is so much thicker. The factory, so much thinner. The only thing I like, it's recessed down. So when you torque it down, it doesn't lift this up. Not like some of the Fords or any of the blocks, the thread goes all the way to the top. And then when you torque it down, it distorts this one area and tries to lift the heads. Here it's even deeper. All right. So that's a good thing. And usually, if the thread go all the way to the top, I chamfer this area here. I put a little chamfer with a factory block. Otherwise, everything looks pretty good. There's still a plus compared to the factory one. Like I said, oil filter pad, same thing there. And there's the part number on this block. Now let us look at the Ford SVO A460 block and the original Boss 429, and the 429 Super Jet block is also similar. Let's look at the difference. You are looking at the Boss 429 SVO block. Note the casting on the front and the 2-bolt main caps. Now let's see the Boss 429. It's got 4-bolt main caps, and look at the ribbing by the front of the casting. There's a lot more meat there. What happened, SVO? The top of the shotgun block has a lot more meat, and also the holes right there isn't quite as big as the factory ones. They're a lot smaller because they have a lot more casting left in them. Look at the bottom end of this block. 4-bolt main on 1, 2, 3, 4, and 5 doesn't have much, but there's a lot more meat there, right around the bell housing. So there is a lot of support. But I preferred it was a 4-bolt main as well for heavy duty use. So I don't know how to explain that, but still better. This is the back of the Boss 9 block. You can tell there's a lot of beef in there, and there's going to be some cutting done to clear the push rods on the top of the deck towards the lifter valley. Also, notice they are all screw-in plugs, and what's coming up here is the eliminator block, so you can see a real quick insight into them. This is the eliminator block for those of you who are more on the serious side of making big power with big cubic inches. This is the block to use. Note the support on the front main cap, a lot of meat there, and also the deeper lifters or lifter bore for big 904 or Chrysler Hemi or Chrysler lifters to retrofit. This is the way to go. Okay, so till next time, please subscribe, like, comment, and share. Thank you very much, guys.